Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about mycelium, plastic of future. So let's dive right into it. Now you have to understand what exactly is the problem. Well, plastic as a whole story is basically a warning sign, and the reason why we have a saying, be careful what you wish for, you might get it. Let that sink in. We have to be very careful what we ask for because we might get it, and this is exactly what happened because we asked for something that is cheap. Okay, granted. We want for something that is lightweight. Granted. We want something that can withstand water, air, soil. Granted. We wanted something that can withstand biology. For example, like wood is a good material, but it does not last against biology. So we wanted something that can withstand biology. We wanted like cheap, we wanted lightweight, we got it. Like scientists are like, your wish will be granted. Here's the deal, plastic. Everything was like plastic is so goddamn indestructible. The only thing in natural ecosystem that can even harm it is ultraviolet. And let me provide context for that. And when I'm saying harming, it does not mean it will break it down to its bare bare atoms. All it's gonna do is basically break very long chains into smaller chains. It's still plastic at that point in time. So that's the whole point. It has a catch. Now, what does that catch means? Catch simply means we can't dispose of it in nature. Now, you may be like, why we are trying to dispose it? If this is a wonder material, why we are not recycling it? Well, that was the first problem. We wanted something cheap. That inherently means it's not financially viable to recycle it. Aluminum has a certain cost to it. That's why it's justifiable to recycle it. Glass has a certain cost to it. It justifies recycling it. Does not apply to the cheap things. And plastic bags, single-use plastic bag, they are free compared to everything else. So fundamentally speaking, we wanted it, we got it, and now we have to deal with the catch. Basically, nature cannot dispose of this puppy for us, and we consumed so much of plastic, meaning so much of plastic has been created since advent of it that it's everywhere. And I mean inside you, kind of everywhere, meaning now we are finding microplastic inside human blood. Yeah, it has crossed the threshold. Like few years ago, I read the articles like, now we are finding microplastic in sea salts. Now it's like, yep, it has crossed the barrier. Now it's inside human blood. So we are getting it everywhere. It's like from food to everywhere. Now on top of that, maybe we are lucky, maybe microplastics are so small, non-toxic, and it's like our body kind of manage it, and it's not like lethal for us. It is lethal for every single ecosystem, and we rely on the ecosystem. We want sea to work. If sea does not work, we do not have a whole ecosystem that relies on it. If we do not have that whole ecosystem that relies on it, we starve. So fundamentally speaking, it's something that we have to take care of. We wanted a magical material, we got it, and we forgot that we had to dispose it properly. We forgot of that. The only way I can even think of taking care of single-use plastic is just making it into fuel. Basically, it's a petrochemical product. You have to just make it down into a smaller petrochemical system, basically longer molecular change into small enough where it's a liquid. At that point in time, you burn it like any other fuel. It's called thermolysis project. It has been worked, but again, we did not lay the foundation from day one. That's why we cannot do it now anymore, because again, we did not think of it. It's like we asked for something magical, we got it, and then we are like, oops, condition applies for there. So that's the whole point. It's a death for eco. Like think of it this way: sea water is one of those things that can destroy almost everything, and plastic is like, nah man, me cool, me cool, me cool, me put it in the sea, me put it in Pacific Ocean patch. I'm like, me cool, we can stand here for 500 years. That's the whole point of it. It's god tier material. So what about fungus? Now fungus has a root. Now what you see fungus as when I talk fungus, and you will see that mushroom kind of system, that's just a flower. What's the main element of it? Mycelium. Mycelium is basically this network of architecture. Now these fibers are very small. Now if you have watched my video about healthy soil, I've talked about these are the reason why soils are either alive or dead, because this puppy are so tiny. From its point of view, plant root looks like a huge trunk. Plant root will look like a highway. Now these are very small, very tiny. What does that mean? That simply means they have the ability to go through even the tiniest pore, tiniest crack. It can just go in and it can extract material out of it. So it's really good, and it has very good space filling efficiency, meaning if you compact biodegradable degradable material, cellulose material there, it's just gonna fulfill it 100% fulfillment. Basically it does not be like, oh, it can't reach here. No, it's like, I got this, I'm gonna reach it everywhere. And this puppy is one of the greatest breakdown agent, meaning it can directly digest cellulose. Cellulose is very hard to digest. Even cows have a hard time digesting this puppy, and fungus is like, I got this. Like fungus is like, me good, I can directly digest this. Now what does that translate to? That simply translates to almost all plant and biomatter, almost all. So flat out, it works on agricultural waste. And all you need is for right temperature, because it is bit kind of temperature sensitive. Do not expect it to work on Arctic temperature or Sahara temperature. It does require a bit of a temperature love. It does require right humidity to properly flourish, and it does not need sunlight, meaning you do not have to worry about hydroponics ground. Again, these things are inherently always there, always present. It's just below the surface. They do not like ultraviolet that much. And again, they don't even need to. Inherently, their symbiotic relationship with plant is like plant provides them with sugars, they provide plants with potassium. Basically everything fancy you see plant needs, these puppies are the one that's providing it in exchange for sugar. So we are like, hey, what if we directly give you something that you can eat? And he's like, eats it and fulfills every blank space there is. That's the role that we are trying to do. And basically we are creating a what we call composite material, meaning structure that you are providing is directly being provided by the mold material. Mold material is like giving you the main structure, and elements of that structure is the biodegradable compost. Now fungus is not going to eat 100% of it. It will try to do, but again, depending on how long you let it grow and how much structural strength you want, you will let it like, hey, sit for 15 days or sit for like 1 month. It's up to you. So that's how it does. It's almost like how you have bricks in concrete. Same thing here. Now aggregates in concrete, same thing here. It is a basically composite material, so strength can be tuned based on the what raw material you fed in, what kind of agricultural waste you put into this puppy. Now, how do we grow this? Well, right now this system is actually in use. Let that sink in. Like actual companies like Dell and other companies are actually using it brick by brick. And packing foam is one of those requirements where we actually don't want packing foam to last forever. It's fundamentally speaking, you have a box, you have a foam inside it, you can collapse the box and store it very efficiently. And boxes are made out of something that can be recycled easily, or it just burned without too much toxins. But you can't do anything about that foam, because that foam, white stuff, it's almost air 98% of the time. 98% air simply means it's too goddamn huge. Physically it takes entirely large amount of space in basically landfill. So we have to do something about it. In those sort of scenario, this packing foam that has been created by Mycelium rather than a petroleum product, it's awesome. Now how do you make it? Like how do you physically make it? Well, simple. You just create a mold for it. Spores, you need agricultural waste, generally hay products and things of that nature, and you have control environment. Now control environment is very critical here. If you control it properly, you can get exactly what you want. If you don't control it, you will get something that is sloppy. If you want something like finished product that other companies want to do, you really gotta control it properly. Control as in like the temperature, the humidity, everything has to be controlled. Airflow, CO2 concentration, all that has to be controlled. And once you do that, basically you have all the things. You put the mold, you put the spores there, let it grow in controlled environment, everything is done. Then you demold it, basically remove it from the mold, and you let it grow again. Now you're like, why? Well, it will fulfill all other cracks, because again, mold will always give you a rough surface. Now rough surface is maybe okay, like let's say you are a boutique system where rough surface may be part of your charm. You will like, what, we do not want a completely polished kind of product, so you will not do that extra growth step. You will directly sell the customer after demolding. But if you will allow extra growth, let's say 7 days of main growth for this puppy, then 2 days of extra growth to give a smooth appearance, then you send it to sterilization. Again, this is a living thing. You do not want to send living things anywhere. You have to sterilize it. How do you sterilize it? You basically cook it in a kiln. Now thankfully it does not require very high temperature, so it's not a very energy intensive process. You are talking about like 80 degrees Celsius. That means like an Indian rooftop we can achieve that. So sterilization is super easy. Now this is a thing that has been worked from as early as 2008. Now there is company, there is patents, things of this nature have been done, sorted, companies are using it, and reality is the numbers are coming in. And only again, economy of scale has not kicked in yet, but at this point in time it still takes less energy to make this puppy rather than basically normal styrofoam, and it produces less CO2. Like it works, like it has been sorted. Like at this point in time, the only thing limiting this is just large scale adoption, meaning if larger company starts to place order, larger company as in like Dell is placing the orders, is like for high end server equipment. If they start to place the order for desktop PC, if other companies like Apple, Samsung, all those companies start to place order for consumer electronics, then the consumption will go up, more factories will be created, and then we'll have large supply chain for that. But right now science is tested, reality is tested, the economic viability is tested, and it works. It's one of those things that it works. It's not like, oh, it maybe work in the future. No, it works. It's here, it's real. And environmental control directly controls what you get out of it, meaning how you ramp up the temperature, how you ramp down the temperature, how you sterilize it, how much extra growth period you do. Environments are a vector that you control, and you can get different kind of feels out of it. You may want something that is very smooth, you want something that is very shiny, very it gives you a biodegradable feel. And what do you do after use? Basically, let's let's say you ship the product, person is happy with that product, they're not going to do ship in replacement. What the hell you do? You break this puppy and throw it on the soil. Just throw it. Don't think too much about it. Just break it, throw it on natural soil. It will decompose in 30 days. Like 30 days, as in like you can make normal time lapse and you will see it decomposing. This part has been sorted. So what other things we can do? I talked about plastic. Plastic has been used with everything. It's everywhere. Now, thankfully, we are talking about something living material. And living material simply means we can do almost all living things that can do with it. Meaning leather. For example, leather is an industry that is suffering. Now, it's suffering simply because of, well, there's supply constraint. You cannot just have 10 trillion cows. You simply can't. Like it takes way too much energy, way too much water, way too much energy. Just raw amount of capital investment is too goddamn high for leather. That's why leather prices are going up and leather demands are going even more up. So companies simply cannot pull up, even if customers are willing to pay. It's like, we're gonna pay you a higher prices. Company cannot fulfill that order because again they have limitation. You cannot just have cattle farm on a idiotically high degrees. There is a limitation to that. So fundamentally they are reaching a supply bottleneck. At this point in time, mycelium leather is a very good alternate. Now why? Well, simply because leather is a bioorganic material, meaning it has a natural feel to it. It is natural, like it's extracted from nature, so it is natural. But mycelium system is really good at that, because many petroleum products have been tried as a compensating alternative artificial leathers. They work. They are one of those things that work, but it never feels good. It never flat out you can no, this is some cheap leather replacement versus now this is some real genuine leather. So in mycelium leather case, it can actually mimic that function simply because it grows exactly like how a organic creature's skin grow, because again it's a biological function. It's not chemistry trying to imitate life. It's like life doing life things that by default gives you the same that you are looking for. And on top of that, because you're controlling the environment, you can create the pattern into it, meaning you can make it fluffy, you can make it elastic, you can make it robust, depending on basically the supply chain. You can be like, for shoe department we have this fungal system that is very good for making hot, solid, hard, rigid stuff. For handbags, ladies handbag, we have this different kind of environment. For clothing equipment, workshop tool kind of apron kind of scenario, we have something different. You get that point. You can control that, and it gives that feel, that main essential part of that. Why people reject a normal leather replacement? Simply because it does not have the feel. This has the feel, and it can actually exceed what natural leather can do because you are fine-tuning it. And the biggest advantage this puppy has is that size, meaning a leather is limited by the cow height. Here it's not limited. You can have a huge roll, meaning as long as you can make the growing pan for it, it can grow into a plywood size of it, or even 10 plywood size of it. Now you're like, why would you want to do that? Shipping is easier, then basically doing cutting on it is easier, then making less waste out of it easier. Everything is efficient if you can make large sheets out of it. Mycelium allows you to do that. So fundamentally it's not a leather replacement, it's a superior leather. And that's what you want. You never want to compromise with something. You always want to be like, hey, instead of using that ugly thing, use our awesome thing. And mycelium leather has the potential to actually cross that threshold where it's like, dude, we don't use animal leather, not because oh, we are caring about. It's like, dude, it's garbage. It does not last as long, it does not have the properties that we want. This amazing. It's lightweight, produces less greenhouse emission, has almost no waste, and we can degrade it if we want to. Everything about it, it has that natural patina. It ages exactly how normal leather does. It's awesome. Same thing goes with meat. Every time somebody is we have meat replacement, most of the time it fails for one core reason. The moment a person, like a meat eater, a meat lover, puts it in their mouth, it's like, yeah, no. Now it's like, why? Its taste is there, literally on a chemical level, taste is there. It's just issue is does not have the feel, texture to it. And this puppy can replicate that texture because the skin, basically the fibers, they are growing exactly like a muscle fiber. So fundamentally it feels same. Basically double blind test, it can cross almost 99% of people can be like, they can't tell which is what. So which means it can act as a true replacement. Thermal insulation for building, and again, thermal insulation wise, it's awesome. It's not a or replacement which eco-friendly. You never want to sell eco-friendly. You want to sell, hey, this is lighter, good, this lasts longer, good, this does not catch on fire and add more toxic fume to your house, good. That's the whole point. This is actually better. And some people are trying to make bricks out of it. Now be mindful, it does not replace concretes and things of that nature, so be mindful of that. However, for small structures, meaning let's say 1-story building or 2-story building, this is kind of good because it does not fatigue cracks at as quickly as possible. So it does have some amazing benefits, and people are thinking about using it in complicated ways where they can bound it with, let's say, rebar or wooden frame, and then get completely organic house, which is far more insulative than anything else. So there are many more things can be done with this puppy. It's just a core material, like how plastic is a core material and you do whatever you want to do with it, same can be done here. Now, what we can expect in the future? At this point in time, long-term testing is still going on, because while this is a thing, this is something that you can buy, this is a company that is providing that, it's real, it's here, everything about it is true. It still is not something that you're like, I do know how this puppy is going to work after 30 years. We don't know. And again, for many scenarios, you don't want this puppy to work after 30 years, for example, shipping. So in those sort of scenarios, it's perfect balance. But what about that insulation? What if it becomes a breeding ground for mold? We don't know. But again, time has not passed enough. Like, we know for a fact that how it reacts to fire, because you can simulate it, you can test it out. You know how it's going to react with humidity, you can simulate it, you can test it. Do you know how it's going to react if somebody pees on it? You don't know. Do you know how it's going to react when a rat starts to make a nest around it? You don't know. Again, those sort of things have to go through real world testing before you're like, this actually lasts in real world. Other properties can be tested very quickly, but real world testing has to still be done. So there are some limitation there. However, the known fact that at this point in time, the known fact is it's flat out does not have the lifespan of plastic. Flat out, like, it cannot match the lifespan of a plastic, and we don't even want to. We do not want this puppy to be like, we put it in a ground and it's like 500 years later it's still there, 10,000 years later it's still there. We don't want that. So that's maybe a desirable or non-desirable, because for home insulation you may want something that's like, what, we really want at least 100 years. Come on, give us 100 years. So that's an issue. Now another aspect is, if this is so old, as in like companies are doing it, as in like it's a product that people can buy, and maybe you have already received a pocket from product from it, what's the consequences? Right now it has to go through patents. Ecovative is generally one major company that is their name is cited most, because apparently they have the largest amount of patents regarding this. Now patents creates an issue. Basically, if an Indian company wants to do that, they still have to pay the patents for them, unless you are in China. But again, that creates the issue for new people to just come in, because before they may not be want to get patents. They may be like, hey, we'll create our own fungal strain where we can get our own patents. You get that point. That's a very hard thing to adopt. Now again, depending on country's government can buy the patent. Country government will like, what, in India we're gonna pay for it simply because we do not want to clean up the mess of plastic. Country can make that choice, and from a country's point of view, it's actually long-term beneficial. So that is still that murky area from a cost point of view. Again, for the original patent holder, it's money maker. For everybody else that wants to replace it, they may be like, what, let's just use plastic. So that's a thing that we have to do. Now the biggest advantage of this is, like, every time you want, oh, I want to do this or I want to do that, there is always a limitation. For example, you want solar everywhere. Here's the, we have surface area, we got the surface area, it's just not cheap enough. Offshore wind, it's not cheap enough. Every time we have some building limitation. This is the only time where I'm like, yeah, there is no limitation. It does not even need sunlight, so we do not have any limitation. Agricultural waste is one of those things that we produce gigatons per day, so more than enough for almost every single packaging need, and surplus leather production, and surplus meat production, and surplus of everything, and we still have surplus left. So it's one of those things that we tangibly do not have limitation. It does not consume too much water, it does not consume too much of anything. Like baking only at like 80 degrees Celsius, that's like one solar heater. And solar heater as in like, solar concentrator running heat pipes directly heating up the chamber, done. That's how easy it is compared to speaking of. That's why like companies are here. Companies are real, they are producing simply because it's cost effective. The only limiting factor they have is they are producing like, only few 100 tons per day. They are not like gigatons per day. Again, they can achieve that. Like physics is not stopping it, supply chain is not stopping that. That's the one ironic thing about it. There is no supply chain limitation on this, and everything about it is awesome. However, still needs some long-term testing. Still have to countries have to figure out what to do about patents, and let's see what we can achieve in the future, because it is potentially awesome. So this was my presentation on Mycelium, the plastic of the future. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.